All right, so we got a definite integral here. And let's see, maybe it's helpful to rewrite this as the square root of a squared plus x squared cubed. Maybe not, but the way at least it looks familiar to what we're working with. Remember, the trig sub is going to help us get rid of that radical. So this is in a form suitable for an a tangent substitution. Remember, this is, well, a squared is just a. So x is a tan theta, which means dx is a secant squared theta d theta. And then we can do the substitution. So we got a 5, and let's change our limits of integration from the start. So if x is 0, notice our tan theta factor here is going to need to be 0. So when x is 0 theta, that's going to be 0 because tan of 0 is 0. If x is a, well, here's a, that means I need tan theta to be 1, a factor of 1. So tan theta is 1 at pi over 4. Let's say dx is a secant squared theta d theta. And if you look at what's going to come out of the bottom here, right, we've got a squared plus, when we square x, here's x, a squared tangent squared theta. And you can pull out the a squared. That leaves us with 1 plus tangent squared theta. And you end up getting the square root of a squared. This is secant squared theta. So this whole bottom is just going to be a secant theta. Right? Now, we can't forget that it's also, I wrote a 2 there. It's supposed to be a 3. It's also being cubed. So we've got to cube this stuff. So we get a cubed and then secant cubed. Okay. So if you look at this, we've got a 5 that's left. We've got a squared on bottom because there's one factor of a up top that'll cancel. So we've got a squared here. A is a constant with respect to x, so we can just pull it to the other side. And then this leaves us with a single factor of secant on the bottom, right? 1 over secant, which is the same as cosine. And now we're just going to integrate. So the antiderivative of cosine theta is sine theta. And we're going to evaluate that from 0 to pi over 4. And we've got our 5a over here. So we don't got to put anything back in terms of x. We don't need our right triangle because we substituted our limits, our x values, into theta values anyway. So we can just evaluate directly here because these are theta values. So we've got 5 over a squared times sine of pi over 4 is root 2 over 2. And then minus sine of 0 is 0. So the answer looks like it's going to be 5 root 2 over 2a squared. And that's it. And I think honestly with this answer, I think, certainly if it was just me, but I'm sure that the WebAssign will allow this too. You can leave these values, these radical values down below. There's something I think I mentioned before. There's really nothing wrong with the radicals down below. This answer's fine. The book might just tell you this is the answer or this, same thing. Okay. Hope that helps. And if you have any more questions, let me know. Okay. Thank you. Take care. Bye.